don't sort anything. Enter these in order because they are paired up. 243, 215, 114, 287, 315, 229, 192, 204, 547. And you can see there's 547 compared with that 562. All right. Anyway, I'm just going to hit quit. And now on a blank screen. All right. Mrs. Calculator. I want to store in L3, what do I want to do? List 1 minus list 2. So everyone look on the front blank screen. Look, if you hit second 1, L1 pops up. I'm hitting minus. If on the front screen I hit second 2, L2 pops up. So far so good? Now we go, where's the store button? Everyone look in the left column, right above the on. You see stow? You see the stow? I mean store. Alright, stow. And I want to store this where? L3.
What is the story again?
Oh, let me back up. Delete. Delete. I want to show you where this are. It's right above the on button in the left column.
Gotcha.
Second from the bottom, still. And it puts an arrow though, it doesn't write still. It's an arrow, it's like I'm going to store all this. And then I'm like, put it in L3. And then and I know it writes it like that, but when you go back to your list, you'll see it there. It's like magic. Hey, let me go back to the list. Where is it? Hey, thanks, there they are. This is what? 3, this is a what? -19. I'm going to fill this in. -14. Some of you already probably filled this out. 9, there's the 5, there's the 10, there's the 36. I scroll down a little bit. What are these other numbers? 12, -6, 5. Last number, the last difference, 15. There we go. I got that? Awesome. Hey, so this whole problem, I'll hit the light, but I'll hit it back off in a second. This whole problem, everyone, section 11.2, match pairs. Once you've done this, it's all about right here. This is our math problem. The differences. That's the data we look at. You really, what about all that stuff? Nope. We're going to look at this. So I want to make a box plot of that, because I only got a sample size of 11 of them. So verify requirements, I just want to make sure it's roughly normal, approximately normal on my box plot. So it's not hard to do a box plot. It's been about a month since we did one though. If we go to second Y to stat plot, I hit second Y. I'm going to have to turn the thing on. Which one looks like a box plot? Oh good, it's already there. But when you get down here, so when I highlighted that one, make sure, put L3 here. If you've got like an L1 there, I have to store L3 and make sure this is frequency 1. I just want to look at it. I want to make sure it's roughly bell-shaped. Cool. I'm going to hit zoom 9. Zoom 9 is zoom stat. Zoom 9 it. Yeah, it's okay. I mean, this is a little bit longer over here, but I can say, this is roughly bell-shaped. All right? Don't let this bug you. Well, that whisker there is a little longer than this whisker.
Can you
Roughly
go back again? What you did?
I sure will. I'm going to hit quit. I'm going to go back to here. I want to make a box plot, but all right, I could have made a box plot of this one or this one. The one we want is the differences.
Difference, okay.
I want to look at that and make sure it's approximately normal. Because my sample size is only a sample size of what? 11, right?
11, yeah.
Degrees of freedom 10. And so I'm going to make sure the box plot is roughly normal. I should also do what's called a normal probability plot. We all should do a normal probability plot. The only thing is, this software doesn't, this calculator doesn't have that technology.
Right.
Minitab does too. That's where it makes those little curves, and we want to make sure all the dots are inside the curves. And I do want to point out everyone right now that it was done, the author did it for us, thank you, with the Minitab software, and all the dots are in the curves, which indicated that the distribution is approximately normal. So we're good to go. But I also wanted to let you know it's good to always look at a box plot, because you don't want any outliers. So when you know this check sheet I gave out to you, if you look at it, that's what it's written. It says, what's the requirements when you do this distribution? It says if n is greater than or equal to 30, You can look down at matched pairs t-test. This is a matched pairs t-test. If n is greater than or equal to 30, or if the difference data, this is called the difference data, comes from a population that is approximately normal with no outliers. So really what I'm looking at, Art, I wanted to make sure I didn't have any outliers. So I'm going to do it again, Art. I'm going to go to second Y, which is stat plot, second Y. I'll turn it on. I'll make sure this thing says L3. I'll make sure I got the box plot there with the outlier thing hidden. Make sure that's entered. So you got to make sure it locks on that. And then I'll scroll down here. And I'm going to hit zoom 9. Zoom 9 is zoom step.
Okay.
Zoom 9. No outliers. Anybody see any asterisks down here? Nope. I should hit the light. I'm bothered.
Is your frequency always going to be 1?
Frequency's always 1. And you go, what do you mean by frequency? One column or one row? Great question. With box plots, frequency's always 1. And I'll talk about finally, I have to enter all this, it takes time, right? I always got to factor that in. If you don't let them do this, give them 15 minutes to type this stuff in. I know that. Hey, when I don't see any outliers, that's good, right? And the normal probability plot did indicate that the distribution is approximately normal. All right? So we're good to go. Is everyone okay with that? Making that box plot? Again, just to review, everyone, I went to second Y. I hit enter. I scrolled down, I made sure this was highlighted, the box plot, then here I entered L3 to make sure it was on L3, and then I hit zoom 9. Good to go. Alright. It's tedious, but we just got to check that stuff, right? Make sure there's no outliers. Alright. So this is great. And when we're going to perform the test now, we'll do a couple more too. Super job with this. So we're only focusing on the what? The differences, right? So all we're looking at is these. So verify requirements, yep, box plot of difference data. Has no outliers. Now whenever you need to write this down because we were told this. A normal probability plot. This would be told to you too. Of the difference data. Indicates the distribution is approximately normal. And thanks for being patient with me with this check, because we should check this out because our sample size is small. We only got 11. So the box plot of the difference data has no outliers. A normal probability plot of the difference data indicates that the distribution is approximately normal. Okay. Are you ready to do the test? Alright, at what level of significance? The level of significance for this problem is 0.05. I'll put that down. Alpha equals 0.05, everyone, that's our level of significance. That will be given to. Hey, if you did your own study, you might choose 5% as your level of significance. Alright? The standard. 5% level of significance. Alright, all we gotta now is perform the test, state our conclusion. Alright. Well, if we perform this test, let's start with the classical approach. See, this is interesting. If you're thinking, what do you do? Draw two different bells? Oh no. One bell. What data are we really talking about? This column, the differences. So this is what's going to be interesting. When we check this stuff, we're just going to use the t-test button. That's what I'm going to do. I'm just going to do a t-test. Use that t-test button about these differences. Alright, so bell right here, I'm going to put a T Just to remind us, we're using t. What's t equal to right in the middle?
0.
So you might do like 1 and 2 and 3 and -1, -2, -3. Where am I shading now? On the left side,
Right side.
or the right side, or both sides?
Right.
Right, it's a right-tailed test. So I always use the yellow chalk. I'm gonna shade out about 5%. All right. Yeah, that'll work. Just shade a little bit. All right, there we go. 5%.
Do it.
Right tail. I need to find, first thing, you know this with the yellow chalk, I'll put the white chalk down. There's something called a T,
Not a ticket, yeah.
it's called the critical T value. I'm not gonna use that calculator until I find T crit. Now there's two ways to do this. If you got a cool TID4, if you're like me, everyone, I've got an old school TID4, it's like the TID3 model. I don't have an inverse T button, I'm gonna have to use this table. Cool. Excel does it too if you have the old school calc like me, if you wanted to use Excel to do
Actually,
it.
mine has
You got inverse T, he's got inverse T. Hey, who does have inverse T? Ah, cool, and some of you like to do it. I'm gonna show you what you type here. Just an inverse T. You can just put the 0.05, that's fine. Don't you have to do like negative or 95? No, this is fine. But you do have to put the degrees of freedom. How many degrees of freedom?
10.
Outstanding. I didn't want you to think you double this up or anything like that. It's just 11 minus 1. 10 degrees of freedom. We're only looking at the differences. Right here, right? Now, when you do this on your calculator, inverse t, those of you who have this function, it's going to give you the negative t crit, but we'll just enter a what?
Positive.
Positive one. That'll work. Well, I'm going to use this table. Does anybody need an additional table? Oh, there we go. Sometimes you misplace it, or you just at home, you kept it at home.
Thank you.
There'll be one on the test, right?
You bet.
Okay.
Have to attach that to every test, no matter what. You get your test, you'll just rip it off with the formulas, tear it off the back if you want, or keep it there. All right, then look down DF10 and look over at 0.05 and match it up.
1.812.
1.812. I'll just go out 2 places, that's good enough. 1.81. T grit? Now what are we going to compare it to? Oh, let's use the technology now, everyone. I'm now going to compare it to this. Did you know this is the same formula we did before?
Mm-hmm.
You go, what do you do? Well, we'll take x bar of what? Which one of the rows? Doesn't that mean a sample mean?
Mm-hmm. So
We'll use the technology to do this, but you like, get the x bar of the differences.
differences, yeah.
Only this row right here. Only this. I'll get the mean of this. I'll subtract it from mu. You know what we said mu was for our problem? Difference of what?
0.
0. So that's really going to be a 0 right there. And then you divide it by standard deviation of the differences divided by the square root of that sample size n, which is 11, right? But if you want to write that down, that's if I did everything by what? By hand.
And yeah.
And we could do this. How do you get the sample? Oh, you know how to get a mean. Add all these up and divide by what? 11, right? You can do all this by hand. Get your standard deviation. Okay, I'll use technology to do everything. Right?
Oh, so standard deviation you have to get
It'd
the
be the
mean
standard
and...
deviation of all these.
Oh, that will be pain.
I know, he's right. If you do that by hand, he goes, that's a pain. He nailed it. So let's use technology to do it all, right? I'm gonna let the technology just give me this number. Right? So we go, where are we going? This is interesting. I'm gonna go to your calculator now. This is a section 11.2. Would you remember this from matched pairs? Watch where I go. Because matched pairs, we have to admit, you're talking about two different means, right? So this could be a little weird for you. You got two different populations here. Two different samples. Guess where I'm going now? I'm going to t-test. And you go, what about that thing right there, number 4? Nope. That's next class. That's independent samples. We're just doing this because we're only looking at one column. We're just looking at these what? Differences. So would you remember this? For matched pair design, I'm just looking at those differences in those pairs of those two means. So I'm going to do this, t-test. Now this is going to be fun, everyone. Like Art said, he goes, if you find the standard deviation of all these numbers, that could be a pain. So, rather than stats, how about error over to data? Don't we have all the data in the calculator? Make sure you highlight it though. All right, let's start out. What's the null? What's the null for the difference?
0.
No, hypothesis, zero difference. All right, where's our differences? What we have to put here?
L3.
L3. Make sure you put L3, that's where our differences are. Not L1 or L2. One of them had 92 octane, the other one. Frequency, what's frequency always? 1. And which one of these? Left-tailed, right-tailed, or two-tailed?
Right tail.
Right-tailed. I like calculating. Okay. T equals 1.14. Thank you. Standard deviation was pretty high. Look at that standard deviation, 14. These are pretty spread out, weren't they?
Yeah.
Look at the data. Something else important to me, I'm going to write it down, is that p-value. What's the p-value? I'm just going to write it down now. P-value is...
0.14.
I hope we all just focus on this. Everyone, we already know our conclusion, don't we?
Yep.
From that one number. That's a probability. 14% chance of getting this. That's not so rare.
Yeah.
We consider anything under 5% rare. We fail to reject a null. So when we do not have evidence that using the 92 octane is what?
Better than
Giving you the better gas mileage. You might look at this and go, but I got a lot of positives in here. Yeah. I just grabbed 11 cars and did this stuff. True, right, but we can talk all about this. There's not going to be evidence. But I'm going to write everything out so you're clear, you know how to do this stuff on a test. You're good to go. There's my T naught. I see we marked this. Where is that? A little bit over here. Give it a little. There it is. Right there, everyone, is my T naught. T naught is about 1.14. But it's not in the shaded region. Oh, sad face. No. Failed to reject.